Hello and welcome back. This is part 3 of the semantic image segmentation videos that we are looking at. In this video, we'll go one step further and see how to manipulate an image based on the output that we obtain from the DeepLab model. Okay. Specifically, we are going to remove certain objects from the image and then restore it back based on the prediction output. First, let's take a look at the demo before moving on to the concepts, and then we'll do a code walkthrough as well. Okay, this is a sample application. So we have the three models that we could load. We'll load the Pascal, and let's select a file, segment the image. So once the segmented image output is present on the screen, so you can click on any of these legends, any of the object classes in this legends. Let's say I click on the background and the motorbike, and I'm going to click on this button, remove selected objects. What this is going to do is it's going to remove the objects that you selected from the legends. We selected the background and the motorbike, so we removed all that, and only the person part of the image is still present. Others are made transparent. Now you can click on restore selected objects to bring back the original image. So all this is done based on the prediction output object that we get from the model.segment call that we make using the DeepLab model. Now let's go to the now let's take a look at the idea behind how to do it, and then finally we'll walk through the code. First, we will load the model as usual. Next, we'll call the model.segment to get the prediction object. So using this prediction object, we'll see what we are going to do. So basically, the prediction object contains 4 attributes: legend, height, weight, and segmentation map. Legend contains the list of objects that the image is segmented into, and then each of those object classes is associated with a color code, RGB color value. So the idea here is to take the color of the legend, the ones that you select on the screen for that particular legends, take the color code, and then match that color against the colors of each of the pixel. So this 0, 1, 2, the first three values of every pixel. So basically every pixel has got 4 values in the segmentation map. The first 3 corresponds to the RGB value of that particular pixel. The fourth value is the alpha value, which is either set to 0 or 255 based on whether you want to make that pixel transparent or visible. 255 is visible and 0 is transparent. So in this case, what we are doing is taking the color, RGB color code of a particular object class, and then matching it against each pixel's color. And then if it matches based on our selection on the UI, if it matches, then if we had clicked remove the object, then we would set the alpha value of that pixel to 0. That's what then that particular pixel would be made transparent, so it will not appear on the screen. So similarly, when we want to restore it back, we see what are the objects that we want to restore based on the user selection, match the color, and then set the alpha value back to 255 so that particular pixel appears again, becomes visible again. That's the idea behind it, to get such an output. Now let's look at the code walkthrough. First, we'll take a look at the click event on the legend itself. When the user clicks on the legend, background, or motorbike, what happens? So this is the function that gets invoked, store object color. So basically, when user clicks on that, the background color of that particular legend is extracted and then stored in an array, in an object basically. So here, if you see store object color is invoked, this is the click event that we get. So we get the target element. So each of those legends are displayed using span element. So we get the target element here, and then from that we get the text content, which is nothing but the legend name, either it's background, motorbike, or person. The next thing that we get is the background color. So this would give you the RGB color value. We extract each of those RGB value into individual values, so we can assign it to an array and convert it into a number, map it to a number, and then we set that objects, meaning the background colon the color. We set the key value pair of the object name to the color in this object colors object. We do the same for every selection of the user on the legend. So once we got all the user selections stored in this object colors object, we'll go back and take a look at the method that is invoked when either the remove selected objects button is clicked or the restore selected objects button is clicked. Both the buttons basically invoke the same method, remove or restore selected objects. So here we get the target element. Basically we understand which button was clicked, either the remove button or the restore button, so that we can appropriately set the alpha value to either 0 if the remove button was clicked or to 255 if the restore button was clicked. The next thing that we do is we get the prediction object. This prediction object must have been populated in the previous step. This is a global variable. This would have got populated when we invoked the model.segment function. So we have that handy. So from that we are extracting the legend, height, width and segmentation map. So the idea here is we create a new canvas element and then draw the source image onto that canvas image. We draw the source image onto the canvas. After that, we get the image data from the canvas. So basically it gives the source images pixel wise color information. That's what this image data contains. So now once we got the pixel wise information, color information for the source image, the next thing we are trying to do is trying to determine what should be the alpha value that we need to set for each of the pixel that we are going to match. If the remove button was clicked, it's going to be 0. If the restore button was clicked, it's going to be 255. So as we saw in the slide, the idea here is to basically compare the RGB color value of the legend against the RGB color value of each pixel that is present in the segmentation map. If it matches, then we either set it to 0 or 255 based on the button click. That's what we do here. We loop through the segmentation map, and then for each of the pixel that we loop, we call this we loop through the object colors object so that we get all the selection of the user. So we get each of them first. So let's say if background was clicked, this would contain the RGB color values of the background. So we compare the RGB color value from the segmentation map corresponding to a pixel to that of the RGB color value of the selected object in this loop. So if this matches, in that case, we set the source image data that we got here, the one that we got here, the image data of the source image. That image is alpha value for that pixel is set to whatever button was clicked, 0 or 255. In this way, we keep doing it for each of the selected object for each and every pixel, so that the pixels corresponding to the object selected by the user either becomes transparent or becomes visible. So that's the whole idea. Finally, we output the image data, the manipulated image data, pixel wise data, onto the canvas using the context.putImageData function, and then display the canvas onto the screen. So that's pretty much the code to manipulate it. So here the I plus equal to 4 on the loop of the segmentation map. This is because every pixel has got, as you know, 4 index positions that it takes, 3 for the RGB color values and 4th for the alpha value. So that's the demo. The entire source code is available in the GitHub repo. You can find it in the description below. And if you want to read an article instead of the video, the description of the blog article for this particular video is also present in the description box. Thanks for watching. Thank you.